Hello guys and welcome to another Maths Guru video, on the Year 12 Further Maths course, and it is similar figures. Yes, similar figures, love, love, love. Now again, we are continuing all the learning from previous videos. If you are watching on youtube.com, welcome, thank you very much. Why not click subscribe and like this little video and hit the little bell notification so that you get advised of new videos loading. And if not, if you are on maffsguru.com, welcome, thank you very much. As you are already aware, you can watch the videos there, have time codes to be able to skip through parts of the videos, downloadable resources, exam questions, and searchable videos, and so much more. So if you're on YouTube and you haven't already done so, zip over to maffsguru.com, sign up, it is free. And you will be able to get all of this content, but in a much better way. Now, similar figures, what on earth are similar figures? Well, by the end of this lesson, hopefully you're going to know what a similar figure is, and you're going to know how to deal with the ideas behind similarity to find missing side lengths. Now, this deals with triangles in many cases, but there's rectangles and squares and circles and all sorts of different shapes that we could deal with. Now, we're obviously going to build on all the work we've done previously. If you haven't watched those videos, they are there on maffsguru.com for you to watch. If you click below, there undoubtedly is something that says previous video, and it maybe says next video. You can zip through all of these videos to try and find the ones that are relevant to you. But I suppose the important question is, well, what are similar figures? My mum always said if you don't know what it is, then look it up in the dictionary, and that's exactly what I did. And I knew it had something to do with ratios. So a ratio is a noun. How exciting, thank you very much. The quantitative relation between two amounts showing the number of times one value contains or is contained within the other. That is a long way to actually say it's got something to do with dividing. A ratio has something to do with dividing. So what I'm going to do is I'm going to look at two squares. All right, can you see the two squares there? Nope, but you now will. There is one square, very badly drawn. And let's draw a much bigger square here. Now obviously squares, all the sides are the same length, and I'm going to say, well, let this be 3 centimeters and let this be 6 centimeters. And what we can now see is that the bigger square and the smaller square have sides in a certain ratio. Now we're going to come back to that in just a moment, because hopefully you'll just turn around and go, oh yeah, the bigger square is twice as big. It absolutely is. And how did we know that? Well, we looked at the ratio of that 6 centimeters to that 3 centimeters, and we said 6 centimeters divided by 3 centimeters was equal to 2, and ultimately there was my ratio. Well, the ratio actually is this divisible sign here. So when you actually do the 6 on 3, that's a ratio. And the great thing is, I know that this side here is 6 centimeters and that side there is 3 centimeters. And what is the ratio of those two sides? Exactly the same. And the great thing about ratios is we are looking for those, those side lengths to be of the same ratio. Then we know the shape has been enlarged or reduced. Now, obviously that is that. So what I'm now going to do is try and throw a curve ball in. There is one square. There is another one. In fact, I'm just going to swap those two squares I used a moment ago around, and let's do my little lines here. Let's call that 6 centimeters, and let's say that there is 3 centimeters. What is the ratio of the sides? And if you say 2, sadly, I have just tricked you. How have I tricked you? Well, because when we do with ratio, we have to know, well, what square are we starting with, or what shape are we starting with, and what shape are we finishing with? And in this situation here, we have 3 centimeters and 6 centimeters. So assuming that this here is my end shape, and this here is my start shape, well, my ratio of sides would in this situation be 3 on 6. And that's not 2, that is in fact half. Everyone out there knows that 3 on 6 is equal to a half. So the ratio of my side lengths is actually 1/2.